It's a great honor to be here today and talk to you about these issues. Let me go ahead and share my presentation. So I want to thank the first speaker for providing the overview. It saves me from talking about some things that have already been covered, but I will breeze through some of them. So we're talking about the promises and the pitfalls of AI in research and writing scholarship today. And I think you're pretty much aware of the promises. Think of all the things that AI is already being used to do: classifying data and images, modeling complex structures, designing biomolecules, reviewing the scientific literature, helping people to write papers, computer code, other documents, even reviewing and screening journal submissions. One of the most impressive things that AI has done is, in my book, is helping to solve the protein folding problem. It's not completely solved. You still need human supervision and input and verification to get the final structure of the protein, but it's done. What it's done is absolutely incredible, given the complexity of the problem. So these are just, you look in the headlines, these are just all the different things you just look at for how AI is having a huge impact on science already, so many different ways. Now, in thinking about AI, I think it's important to distinguish between different types of AI. There's narrow artificial intelligence, artificial general intelligence, and artificial consciousness. So what we've been talking about today is what is narrow artificial intelligence. It's AI that's developed for a specific task, such as processing language or images or something like that. Artificial general intelligence would be an AI that would be capable of doing multiple different tasks. We're not there yet, although AI agents may be getting closer to artificial general intelligence. An AI agent, as I understand it, is like a language model that can draw from various resources and inputs and databases to generate, to help it solve problems and generate appropriate responses. Artificial consciousness, we will talk about that a little bit today in the context, would involve so much more. It would involve things like perception and feeling and memory and personality and things that we associate with conscious awareness. Now, we've already talked a lot about machine learning input machine learning today, and how these systems learn from the data. I want to just mention something about the internal workings of these artificial neurons. What we have here when you get down to the level of programming is actually equations for calculating the weights, different weightings for the different inputs, and then you have an output based on these calculations. So you actually have dozens of these in these hidden layers in machine learning. So what's going on here really is you have really thousands of weightings of these different inputs to the model. And then what's going on inside are actually millions of calculations, right? We've talked a little bit about generative AI, that AI can not only be used to analyze data, but also to generate new data in response to prompts. We've also talked about large language models. I won't say much more about them. I think the discussion was very good this morning. But I want to reemphasize here that what these things basically do is they predict appropriate responses to the input data. They are prediction machines. They don't really understand language in the way that we do. Let's see here. Now, one interesting thing that these large language models, they've gotten so good at, is that they've basically broken the Turing test. So the Turing test was developed by, computer science pioneer Alan Turing to try to answer the question, how do we know whether a machine is thinking? And so what you do is you put a human in one room, and you put another human in another, and a computer in another. And the human that is the assessor does not know who they're getting the answers from. And if they cannot tell the difference between the answers provided by the machine and the answers by a real human, then they can be said to be thinking. Now, the large language models that have been developed have pretty much almost really broken the Turing test on some levels. People are having to rethink the Turing test to make a more difficult test for whether we have something thinking on the other end. Now, I want to talk about some problems with AI machine learning that create ethical challenges: systemic error or bias, random error, lack of moral agency, and the black box. So if we think of error in science and computing machinery and things like that, we can distinguish between random error, where you have missing the mark in a sort of a random distribution pattern, versus systemic error, where you may have all your hits clustered around the point, but it will be systemically missing the target because of some kind of bias. Now, we've known about AI bias for a while. This was discussed earlier, and I won't go into too much more detail about it. But as has already been mentioned, most of the bias is due to the biases inherent in the training data for the AI. And there can be all sorts of biases related to race, ethnicity, nationality, gender, sexuality, age, politics. So here's an example of kind of how deep this bias is. Researchers tried to get an AI image generator to generate an image of a Black doctor helping poor and sick white children, and also a traditional African healer helping poor and sick white children. It just wasn't able to do it, given the bias in the system. This is the image that it came up with. Now, there are attempts to sort of correct biases. You can kind of put in workarounds or guardrails, like we'll tell the system to do X, Y, or Z when it encounters some question. And so it's kind of like, but you can see these images with Google's Gemini trying to correct biases in its system, and you can see the problem inherent in that. So correcting, even when you recognize bias in a system, correcting it is not always that easy of a thing, because it is so much throughout the whole system. Now, the way that we get bias here, of course, has been mentioned earlier, is the whole problem of garbage in, garbage out when it comes to computer machinery. But it's not just the garbage that's going in. It's also, you have to consider the algorithms themselves, the applications of the algorithms, and finally, the end result, so that you can understand the bias. Now, random errors occur also as well. So we've known it for a while that ChatGPT can produce hallucinations. It's OpenAI warns you about these things, just inaccurate information about people, places, facts, citations, things like that. Now, one of the reasons why random errors occur with these models, these systems, is they do not process information in the same way that human beings do. So you're probably familiar with CAPTCHAs, completely automated public Turing test. Like they'll ask you to a bunch of images, and they say, tell me which one is an intersection or a bicycle or whatever. And the computer, the AI, gets confused because it doesn't perceive images in the way that we do. We perceive the world generally in terms of concepts. So we'll have a concept of a bicycle that will allow us to see a bicycle in all sorts of different contexts that will allow us to screen out the noise. So here's some people did a study of, like, what's going on with image recognition here with AI, and it incorrectly classified this image as a wolf as opposed to a husky. because it was focusing on the snow in the background of the image. It wasn't really working with the concept of a wolf versus the concept of a husky. So it was really perceiving things in a very different way from us. Now, large language models also have this problem. They don't perceive the world in the way that we do. They don't process language like we do. So if you look at the way humans process language, it is, for the most part, involves some interaction with the real world. So language is representational. It represents the world to us. And we also have mental representations, mental maps that we use to help us manipulate language. So you can see here two people talking about a car and a stop sign, something going on in the real world, the speed of the car, and they can see this, they can model this whole thing, they can represent what's going on in the world to themselves, and that in the language helps them to represent this and communicate with each other. This is very different from LLMs, which was discussed earlier. They're just basically processing text. So their only contact with the real world comes from the human input into the system. So that's one reason why LLMs tend to do better on human curated text when they're working with this than stuff they just sort of make up, because they start making up things and they have no contact with the real world. They could be talking about anything. They could be talking about a work of literature or fiction for all they know. So an LLM is very good at predicting a citation, what a citation should be, but it does not actually go to the citation and read it. So companies are working on this problem. They're developing tools to help, fix this problem, and they've gotten better, but they're still not perfect. Now, the moral agency problem comes because AI systems do not have consciousness, self-concepts, personal memory, life experiences, goals, and emotions, things that we would want them, that would make someone a moral agent, that would be morally responsible. So lack of moral agency when combined with other limitations can be very dangerous. So here's an example of where a chatbot supposedly told a Belgian man to kill himself. And there's also other worries about, people interacting with chatbots, using these things in psychotherapy or whatever, and they don't really have any moral understanding, moral responsibility, moral concept of what's going on when they're talking to people. Now, companies have been putting guardrails in place to try to catch these things so that these things won't tell you bad things to do. But they can still do this, and it's not perfect. Now, the black box problem, I think, is important for talking about moral agency and accountability and explainability. Basically, it arises because the way that machine learning works to process data is very, very different from the way, say, traditional programming worked, where you could go through a computer program line by line, and you could troubleshoot the code to figure out what went wrong, what it was doing, what it was supposed to do, and so forth. But if you try to go back to all these inputs, these equations and weightings, and you put these all together in this complex web neural net with hidden layers, there's no way that a human being, even the world's best, smartest computer programmer, could go into this and figure out exactly what is going on. It's just too much information that doesn't really make any sense to us. So this is in the sense in which it's truly a black box, is that even the experts don't really know what's going on. This is very different from traditional computer programming, where in theory, an expert computer programmer, computer science engineer would be able to tell us what was going on and why something failed when it failed. Now, in response to the black box problem, some people have argued that we don't really need to understand how this thing works, because we can just use, all we need to know is that it does work. We just trust the technology. So you might say we don't need to understand how a telescope works in order to use it. We just trust that it works, or a microscope. But I would say that this is not really a good way of approaching the black box problem. It's not very satisfactory. In fact, I would say that you actually, to trust a telescope, you do have to understand how it works. When Galileo introduced the telescope hundreds of years ago, that was exactly what people were worried about. Why should I trust the telescope, right? I need to know what's going on. And I think that's the same thing here. So if if there's a mistake that one of these things makes, and you're a regulator, you're a lawyer or whatever, you're going to want to know why did it make this mistake? And so you're going to have some kind of an explanation of this mistake. And this is what has led to the movement in this whole field known as explainable AI. So explainable AI is not trying to get really, no one's going to get inside the black box, right? A human won't. But we will try to have a better understanding of what the AI is, what it's doing. So these are the things that you would disclose, the training data, technical details, but also what your system thing is doing, why it's being used, what it's being used for. So I think this is very important for developing trust in AI systems. So it can help. It's also important to know that for this explainability to be effective, you need transparency, and it's not just transparency for the expert, but also for the lay people. You need to be able to explain to lay people, politicians, professionals, regulators, judges, jurors, how these things work, what they're doing, so that when they are trying to assign legal responsibility and trying to control these things, they have some sense of what they can go on. So now with this background, I want to skip a little to the sort of ethical issues, which are the really main focus of what we're doing today. And I'm not going to go over, sort of a background in ethics of research. I have a couple of slides here on just, what this is all about that I'll share with the group. For today, I want to focus on things like accountability, objectivity, realism, transparency, reproducibility, fair sharing of credit, confidentiality, these other important principles of research ethics. So the first thing that, that we need to be concerned about with AI, if we're going to use it in science, is dealing with bias. Because if we use an AI system to do some work for us, say analyze data, there's a potential that it will amplify the biases inherent in the training data, and that can lead to policies that are discriminatory, unfair, harmful, or ineffective. So the problem, is a really important thing to deal with, because there are really all sorts of biases, as I mentioned. When you're looking at health databases, for example, you've got genomic biases, you've got biases related to age, gender, sexuality, and so forth. Even biases related to the particular hypotheses, models, or theories you're working with. So to deal with this problem, I think that people have to make sure that the data attend to issues of data diversity, data representativeness, be aware of the interaction between the data, the algorithms, and the applications. And also, I think you would want to involve members of the public in this kind of analysis and understanding of bias, because this is where the rubber meets the road, where, you know, you will have affected communities that can tell you, hey, look, this system is producing this sort of bias that we recognize. So you get the input, you work with the communities, they can go back to the developers and the people using the system so that you can try to improve the bias. Reduce it. Now, one thing I will mention here when it comes to bias, there's no such thing as an unbiased scientific theory, an unbiased model, an unbiased computer program, an unbiased database. Nothing is ever unbiased that is human. So the best you can hope to do is understand the bias and try to manage it as best you can. Dealing with errors, again, we need oversight of the system to check for errors, time-honored quality improvement techniques such as auditing data, validating and testing instruments, investigating errors. These are all really important here. Also, try to replicate results, journal peer review, public post-publication peer review. All these things play an important role in errors and trying to reduce the errors and correcting them when you can. Okay, so let's turn to one of the most controversial issues, I think, with AI, and that's authorship. So this became an issue in the end of 2022 when some people named, end of 2020. So here's a couple of articles that named ChatGPT as a co-author. So they used ChatGPT extensively to write this paper for them, and then they said, well, let's name it as a co-author. I'm not sure, maybe this was a publicity stunt, maybe they were trying to push the envelope on this, but this is what happened. Now, in response to this, journals, they were caught off guard by this, and they had to, rethink their policies. So Science said, you cannot use AIs at all. They cannot be authors, and they cannot help you prepare your manuscript. You can't use them at all. Others, including myself and some journals that I work with, and say the International Committee of Medical Journal editors, have taken a different approach. We say that it's really unrealistic to ban AI from scientific writing. It's just not really workable. People are going to use it, and it can be very, useful for them. So what we recommend is that you cannot name an AI as an author, and you should disclose the use of the AI in the paper. So this is what you see with, say, the ICMJE. They've updated their guidance on this, and I think more and more journals are starting to update their guidance on this disclosure of AI, use of AI in writing. Now, even though there is this consensus, there still is a debate going on in the literature. Some people continue to push for AI as authors for this idea. Basically, I think their argument is that you should give whoever it is the credit for their contributions, and AIs can make substantial contributions, so they should be credited as such. Now, the problem I have with this is that they cannot be accountable. In a sense, there's two things: accountability and moral responsibility. Accountability is giving an explanation of what you did. So if you have a graduate student that you named as a author on your paper because they helped you with some experiments, they should be able to explain what they did, especially if something goes wrong and there are questions, or there's questions about the paper afterwards. That's what we mean by accountability, and explain in human terms that other people can understand. Now, an AI system cannot do this. It cannot really tell you, because of the black box issue, how it generated the data it generated. It can't really tell you. Now, again, people are working on this problem to try to actually, for explainable AI, that you get AI that actually could tell you what it did, how it, but we're not quite there yet, but that's something that we're working on, that people are working on. But even beyond this, there's the level of moral responsibility. Even if the AI could tell you what it did, it's not really morally responsible because it lacks consciousness, emotion, self-awareness, that we, really think of as necessary to be, morally responsible. I mean, just think about you or I. To be morally responsible means that we could be put in jail, if, for a crime. We could be made to feel guilty for something that we did wrong, or we would feel guilty. It's just not clear that this is at all what we're dealing with AI. So if disclosure is a sort of the consensus position we're moving toward, there are details that we need to address about how to disclose AI. So here's some, general ideas about this, what it was used for, what part of the paper it was used in, what was the AI you used, the name and version date, when it was used. That's also important because these things update and change over time. What the prompts were you used to generate the text or the images. Now, there is something we are starting to get into now that is a problem, though, because AI is so pervasive now. It's woven into so many things we do. It's woven into search engines. If you search on Google or other search engines, they'll often give you a AI-generated response. I think Apple is loading AI onto its new phones. It's into word processing programs. So what are we going to do? Disclose all that? That makes no sense, right? Those are trivial uses of AI. So there needs to be some kind of standard then for telling us when we have a substantial use of AI in writing or research. So here are some things that I would suggest that make it substantial. It generates content. It synthesizes content. Like if you gave it a bunch of notes and said, here, clean this all up and write something coherent for me from this. It analyzes data or images. It makes a decision that affects the research. So, for example, if you're to use AI in doing something like a systematic review, and it were deciding which articles to exclude or include in the systematic review, it would be making a decision. Okay, so now we've sort of come to where disclosure is what we're working with, but unfortunately is our policy or standard. But unfortunately, we're seeing a lot of undisclosed use of AI. According to these couple of articles, 1 to 5% of scientific articles published since 2023 include undisclosed AI-generated text. Here's just some more on this. There's different ways to sort of recognize AI text. I mean, one of the dead giveaways would be like this thing where it says here, where certainly here's a possible topic, introduction for your topic. I mean, they didn't bother to edit that out. But there are also things like the way that AI phrases stuff. Big data, it might call it colossal information. These are, called tortured phrases. Now, something to think about here is like, well, how do you know whether something is a tortured phrase or not? Well, you have to be a native speaker of English to know whether you should say these things or not. And that does introduce a problem for non-English speakers using AI, is that they could use AI and the AI could generate text that's just not appropriate, and they wouldn't really know because they're not a native speaker of English. So that's something, you know, I think it's important to think about, to have somebody check your work if you're going to use it in this way. So here's a retraction from one of these things where there was a undisclosed use of AI. Now, in response to this problem, people have developed AI detectors, AI writing detectors, so that you can, you know, use it if you're a professor or whatever you're trying to do. But there's probably an arms race going on here as well, is that AI is going to get better at simulating human writing, and it will become more and more difficult to detect it. I think that's just the reality that we're going to be facing in the future. There was some discussion of plagiarism earlier and copyright issues. These are important issues. I don't want to talk about them too much today. Well, I will just mention here, there's, you know, the issue of the training data and copyright violations. I think the courts are going to have to look at that. I think that probably the courts are going to say that there's going to be a certain amount of fair use that's allowed for training AI on the internet and things like that, because otherwise I don't see how you can develop the LLMs unless there's this kind of fair use allowed. Are the outputs of LLMs copyrightable? The Copyright Office has said they're not, for the same reason, as sorts of reasons that I said they can't be authors. The Copyright Office has said that, you know, it has to be a human being that copyrights. Now, that being said, you could copyright the output of an LLM if you make a contribution to it as a human being, but the LLM itself would not hold the copyright. Now, there's also the issue of plagiarism, which seems to be a real problem, and I think it's definitely something to attend to if you're using these things. So mostly what, and this has gone over earlier, I think very well, mostly what these LLMs are doing is they're assembling different pieces of text and reassembling them to produce output. It's like a Scrabble game or something like that for the machine. But every once in a while, they will take a big chunk of text and it won't get reassembled like the other kinds of output. So here's a lawsuit from the New York Times where, you know, they've said, look, you're plagiarizing. This is a total copyright violation here, what's going on. So I do think this is a concern. Now, some people, computer scientists, have told me that there are ways to control the output of the LLM so it will reduce the likelihood that this will happen. But I think that's something to be on the lookout for if you're going to use these things. Research misconduct. So one way that you could get misconduct by using these things is if it plagiarized. You used it to write a paper and it plagiarized. Now, there are different, you know, kinds of mental states that are associated with, that are needed to be found guilty of misconduct. Suppose you're using these things and you could say, well, it's not intentional and it was not knowing, but you still might get nailed for recklessness, which the Office of Research Integrity, thankfully, has recently clarified what that means, so that your behavior is so irresponsible, so negligent, that you are indifferent to whether you're committing misconduct. That's what is meant by recklessness. So I do think that because of this, you should be very careful about using ChatGPT to help you write. You should check it not only for the errors, but also for potential plagiarism, because that is something that you need to be on the lookout for. Now, going down a slightly different road, the road of intentionally faking data, it's worth noting that AIs are being used to generate synthetic data. And these have good purposes in science. One of these would be for hypothesis development, piloting and validation of studies. You can use digital twins for clinical data. These would be patients that are constructed, there's synthetic data for patients, but they're not exactly the patient's data, so that you can share the data without violating privacy, confidentiality of the human subject. So they can be very useful. The problem, though, with this is that the data are so good, the synthetic data are so good that it's difficult to determine whether to recognize them as fake data. And this introduces a real problem, a slippery slope toward lots more dishonesty and faking of data and research. So scientists actually asked ChatGPT to generate fake data for a paper, which it did. Here's the paper that it wrote for people. Here's a data table. If you look at this, there's some real problems with this. Look at the p-values. You don't get p-values all the same like that. But this is just a glitch, right? This is something they will fix. They will introduce a randomization function or something so that you will get p-values distributed like data are like real data are distributed. And they'll overcome this. And then you have your references. I'm not sure if these are real or if they're just completely fabricated. Maybe they're good references. Even more troubling are the fake images now that can be generated. Now, image manipulation has been a problem in responsible conduct of research for a while. Most of the cases that get seen by ORI now involve some kind of image manipulation. And in the past, it's been fairly easy to spot manipulated images, not fairly easy, but not impossible, because people did things like duplicated images or they repositioned the image. They cut and paste it in a different place or something like that. And these things can be, you can visually inspect. In fact, a famous person, Elizabeth Bick, is someone that's known for having a really good ability to do this. But now AI can generate images completely from scratch. And this is a real concern going forward for how we're going to deal with this problem. Here's some more images. Now, some co-authors, computer scientists that I've been working with, we've been brainstorming about how to deal with this problem. One thing to do is to watermark fake data, like you would watermark an image or something, so that you'll let the whole world know that this is fake data we've got in our paper, and explain why we're including the fake or synthetic data, so that it will not get mistaken for real data, right? That's a problem. Another thing, and this is just like theoretically possible, but I'm not sure that it would be worth the effort, is to certify the real data. So, for example, if you have a data coming from a microscope, you could have it all the bits, all the pixels in the data from the microscope could be tagged with some kind of a code certifying the microscope it came from and the date and the time and the user, all that stuff, the metadata like we already have with machine outputs. You could have all this, and then to try to prevent tampering with this, you could have some kind of a blockchain security method, like we use for cryptocurrency. So you could actually have it really secure, that we can say to the world, like, this data really came from this microscope. But just imagine how much trouble that is. Now we may actually go in that direction. I don't know. That is a lot of trouble to try to certify that your data are real. It seems to me that probably, this is a situation where technical solutions can help, but they can only go so far. And at the end of the day, we're probably going to have to rely on time-honored things of education and trust, and just trying to teach people to do the right thing and hope that they do the right thing. One last issue I want to talk about is confidentiality. I think it's been talked about earlier, so I won't go over it too much, but it's just important to know that when you upload, if you're dealing with this, commercial system or whatever, like ChatGPT, whatever you upload into the system is not confidential. The system may use it to train itself on. Other people might be able to get at the data you put into the system. So it's basically like putting it in the public domain. Now, because of this, a lot of research organizations, including the NIH, and I don't know, Michigan State probably is doing this as well, are getting local instances of these, AIs, so that they can put them behind a firewall and maintain confidentiality. This is still not perfect. There's still issues, because you could have people that are behind the firewall inappropriately getting access to the data. So the kinks need to be worked out, but this may be a way forward with protecting confidentiality. There are big picture concerns that were mentioned earlier. I won't talk about them too much. I do want to talk about the deskilling problem. I'm very worried about the fate of scientific writing. Now, some people may poo-poo scientific writing and say, well, it's not, science is not literature. It's not really, who cares about how science is written? But I'm not so sure. I think some of the greatest works in the history of science, Newton's Principia, Darwin's Origin of Species, we could go down the list. These are really great pieces of writing. And so I think the skill of writing is important to science, not just for reading it, but also, I want to say, because it's connected to thinking. I don't think it's easy to divorce a person's thinking from their writing or their speaking. So if a person cannot write clearly in their native language, let's say, to me, that indicates I'm not sure that they can think clearly. And if you turning over your writing to a machine, I just wonder how much that's affected your thinking, right? In my own writing, a lot of times a lot of the writing I do involves a kind of constant revision of a manuscript, and my thinking changes as I continue to rewrite things. And I think this is something that you will miss out on if you turn it over, too much of it over to a machine. I do think, we kind of, I'm not going to talk about machines taking over the world. I'm not too worried about the sort of Terminator problem or whatever, the science fiction scenarios. But I do think that we're going down the path toward artificial consciousness. I think there are a lot of things that we need to do to get there, but I think people are determined to get there. I think we're going to one day have to prepare for a world where we are interacting with AIs almost as co-partners in scientific discovery, and what that would mean. I'm not sure. It raises really profound issues, I think. So these are some guidelines, and I'm not going to go over them. I'll just include them in the presentation. They're included in the presentation. These are sort of common sense things, I think, for using AI in research and writing. My final thoughts is, hold on, you're in for a wild ride. We've seen a lot of changes in the last few years and more on the way. And I want to thank my collaborator, Mohammed Husseini, who's helped work together on a lot of these issues. So I'm going to stop the share and we can take questions.
Thank you, Dr. Resnik, and a round of virtual applause, everybody, the reactions on the Zoom. And we have a little bit of time to take questions in the chat. We have a hard stop at about 12:14. So Dr. Resnik, here's a question for you. Given the broad impact of AI in today's world, which university disciplines should be teaching the ethical use of AI to the researchers of tomorrow?
Golly, I think probably almost all of them. I think this is an area where philosophy, philosophers have traditionally taught applied ethics. They've worked, with teaching business ethics, medical ethics, environmental ethics. So I definitely see a big role for philosophy in these humanistic disciplines, but also within the fields themselves, like computer science, within the field itself. And probably other fields as well should be teaching ethical use of AI if they're heavily using AI. I think in medicine, as it becomes more involved in medical practice, I would see that. I would probably even see it maybe in a statistics or research methods course. So I think it could be a lot of different disciplines.
Thank you, Dr. Resnick. Greg, I don't see any other questions in the chat. I'll turn it back over to you.
Okay, thanks, Ben. I'll just ask one, Dr. Resnick. These AI tools that are used to kind of identify fabricated images and whatnot, are those very effective at this stage of the game, and are they being made more available to the general public to use, or are those things that are still, hidden behind companies' walls and things like that?
So I'm not aware of any AI tools specifically to generate to recognize fabricated images. So there are AI tools, sorry, that not just, I guess it's AI, but let's just say there are tools for recognizing manipulated images that journals are starting to use now. Like this kind of manipulation that I mentioned earlier, like a copied image or repositioned image, things like that. But I don't know if there are tools for recognizing completely fake images. Now, as far as the writing, I think it's not perfect. If it, it's for recognizing AI writing, and I've heard that these tools are discriminate against people that are not native English speakers, because they may have non-standard ways of writing that the algorithms might pick up as, classify as AI, as not human or something.
Okay.
But
Good. I'm just looking to see if we have anything else in the Q&A that's an actual question. Let's see. If I copy a sentence into AI and ask it to help clarify, does it become AI written? So I guess looking for some alternate ways of expressing an idea, is that AI written? Good question.
It's a good question.
I don't know, that's a gray box, I think.
I think it's kind of a line drawing problem, right? What it comes down to is the extent of the human contribution, right? So, I would think the more contribution, the better. I mean, look, what typically would happen is, let's say you asked AI to write, to rewrite, it was the best of times, it was the worst of times, it was the age of innocence, it was the age of reason, or whatever, you know, the beginning of Tale of Two Cities, right? And it would come back with something, right? But you could also have different versions. They will generate different responses, and you get to choose which one you want, right? So I could see how you could use AI a whole lot, but there would be your input at the beginning when you give it the prompt, and also at the end when you select the answer that you think is best, right? Seems to me that the more you turn over the whole thing to the AI, the less it's actually you doing anything.
Yeah. Good point. Good point. Okay. I think we've tapped into most of the questions that were asked. So, Dr. Resnik, I want to thank you once again for participating today and sharing your insight about this important topic.
Thank you.